All right, thanks, Min. Like Philip said, my name is Matt Kelly with the Boeing Company. I'm the working group lead for the tools working group. So we'll just dive in. So a little 2023 recap. This working group was in kind of an interesting state. It had been going on for several years, and it had gone kind of dormant because the working group kind of considered its original mission complete. And that original mission, we'll talk about it a little bit more in a slide or two, but that was mostly to train up kernel contributors and to look at static analysis violations and submit patches for them. And that pretty narrow scope allowed them to kind of complete their mission. They trained up several different kernel contributors. There's actually still nightly CIs and fuzzing tests that are out there. And we can, I'll post the links on our GitHub soon. And you can go see those. But the activity of the actual working group itself and the meetings kind of went quiet because several people were trained up. And then once you're trained up, you don't really need to go attend the meetings again. You just go off and do your job. And the TSC kind of had a desire to keep this working group going. And so we talked about broadening its work scope. So first, I want to say thank you to Lucas for leading the group for its first several years of inception. And then I took over in October timeframe. And we're looking at how we can kind of broaden the work scope, what other activities we can pull in. The one thing that also was definitely going on this year was we continued supporting CI activities. Sudeep has done a bunch of great work there across automotive systems and medical. They each have their own CI running, and they've done some interesting new things this year, including the integration of OpenQA. I think Philip mentioned another interesting one there that I kind of forgot, and it was stuck in a Zoom chat, so you can chip in the chat if he wants to add that. So what are the current activities that we're working on? One of the primary and probably most important ones is kind of reworking the mission statement. So you can see the original mission statement here. The working group focuses on the application of tools, handling of tool results, and improving the kernel based on the tool's feedback. Like I mentioned, that's a pretty narrow work scope, and the group was able to do that. We have static analysis and fuzzing runs running every night. You can go look at them. You can use them to submit kernel patches. We do want to, as it relates to the original mission statement, we do want to kind of clean up and migrate a lot of the guidance about kernel contributions into our new GitHub. But otherwise, that original mission statement is pretty well complete. The new mission statement, we really just try to tweak a few words to open it up quite a bit. So you can see focuses on creation, analysis, and application of tools and techniques to contribute to the improvement of the kernel for use in safety cases. So I think just the addition of a few words opens us up to a lot of new activities here. And we have a list or a potential list of things that we're going to pull in. And as far as this working group mission statement goes, we haven't actually officially changed this. So I'm really looking for feedback if people have ideas, suggestions, or just general feedback on the mission statement. We'll look to actually formally change it in kind of Q1 of this year. But I'm definitely open to feedback. We did have a session or two with a few small sessions with a few people working on this kind of improved and broader wording. Otherwise, another activity we're working on, which is pretty important, is increasing the engagement. So as I said, the group had kind of gone dormant because their mission statement was kind of complete. And so one of the big things is to pull more people into the working group, both internally and externally. So we're working on some blog posts to advertise what we're doing, LinkedIn announcements, presenting at conferences where we can. And I think, here we're trying to find new topics that really engage people's daily work so they actually stay involved. I think the challenge for a lot of us is that sometimes the work that we're talking here doesn't really impact our daily work. And so it's hard to prioritize it and actually contribute. And so we're really trying to focus on those kinds of topics that actually help people in their daily job. The other thing we want to do is increase internal engagement. So I'm not really looking to pull people from other working groups, but I'm looking to increase the collaboration, if you will. So we're supporting the CI for several groups, like I mentioned before, but what else can we do together that will really increase the quality of our products? The other current activity, we're adopting some existing tools. So there's two tools, two major tools that have come out of the other working groups. One is called Basil. That's a tool for software specification analysis and testable requirements definition. So it allows you to link across various artifacts and show kind of how those artifacts link together, which is super critical to the safety process itself. That development is being led by Luigi. And these tools, we just pulled them in and had our first meeting about this last week. So we're really trying to figure out what exactly it means. But we want to see if we can spread the use of these tools, increase the engagement and development on these tools. And we'll see where it goes. The other tool is KSNav. This is a pretty neat tool that actually takes your kernel binary and analyzes it and helps you create function call graphs and other kinds of interesting diagrams based on the actual built product. And it's really neat. That development is being led by Alessandro. And like I said, these two tools came out of existing working groups. And so one came out of systems and one came out of automotive, and I couldn't remember which was which, and I didn't want to get it wrong. So I left it off, but somebody can chip in the chat on which one came from which. Okay, and then 2024 activities, where are we going? We had several discussions around this. There's a ton of potential topics. And actually, we had these discussions before we formally adopted those tools. So we can basically add those tools to this list as well. There's a ton of topics that we could talk about. I kind of narrowed it down to the couple that I think are probably the most interesting. This group was kind of previously focused on static analysis, of course, but mostly focused on kind of actually running these static analysis, fixing things, and contributing back. I think there's kind of if you step back, there's kind of a broader question of how we approach the application of coding standards and static analysis to open source products. How do we engage communities? How do we reconcile the coding standards that a project is using with the coding standard that a certification authority might deem worthy of actually using for cert? There's lots of things to dig into there. And how we can contribute to the open source tools that are out there to make them more viable for a safety certification process. Like, could we contribute directly to Clang Tidy or Clang format to, make it address very specific safety rules in a way that helps all of us. Another one that I think is really interesting is kernel testing. I haven't seen this discussed too much across the groups. Of course, I'm not able to attend all the groups at all times, but I think we need to engage the kernel community on testing in a more systematic way. Because for safety cert, we obviously have certain requirements. Oftentimes that comes down to coverage. And if you look at just the general coverage, it's not that great, as you might expect, because there really hasn't been a coordinated effort. And so here, I think the beginning ideas are kind of dipping our toes into the water in terms of trying to actually write some K-unit tests and maybe even converting some of the existing runtime tests, the old runtime framework, to K-unit tests and things like that. Lots of space to work there. The other one that I think is really important and is really not my area of specialty is tool qualification. So most industries and their standards have some sort of process for tool qualification. In aerospace, that's DO-330. And that's an area where it certainly seems like the tools working group should address that. And so we're kind of seeking out some experts there, who actually knows about tool qualification and could help us refine the approach in this topic. How do we qualify an open source tool? To my knowledge, that hasn't been done yet. And so I think there's a white paper or something like it to be had there about how we would approach qualifying open source tools and how we might actually kind of standardize across industries, because each industry has its own approach as it stands. All right, and then lastly, just a call to get involved. How can you get involved? We have 2 meetings a month. We tried to stagger them a little bit so that it hit most people's availability. So we have a second Tuesday of the month meeting at 9:30 a.m. Eastern and a fourth Thursday of the month. I'll have to correct that in the slides. Fourth Thursday of the month at 11 a.m. Eastern. And of course, you can always jump into the mailing list with the link there. And then I link to our various GitHub pages, the tools working group itself. With that tools working group, we're looking to increase the quality of the onboarding material. It's a little thin right now. We're going to work on that in the near term. And then there's links to the two tools that I mentioned before, Bazel and KSNav, that are kind of the main thrust of our activity right now. And with that, I open the floor to any questions.
Thank you, Matt. Was very good insight, I guess. If you would say this is the one capability or topic where people can support most, or where you say this is really in the field of expertise where we would like to get something, do you have something in mind already, or would you say, well,
yeah, I think the best
so
yeah, tool qualification is the one that I think it just feels like this working group has to address in some way, and we don't have the expertise in that area right now, I don't think. As far as where you can jump in and get involved right away, I think it's working on the existing tools, Bazel and KSNav. If those benefit your current efforts, that's probably the best way to jump in and actually produce something interesting. So.
I think for others, if you're hesitating to unmute, of course, you could also just type the question in the meeting chat. So this is also always an option. Okay.
Maybe one question. Do you want to use open source tools, or we could use in the process also some commercial tools?
Yeah, that's an interesting question. I think specifically as it relates to tool qualification, I'm guessing, or just in general.
I mean, if we have tools that we buy and that they are already qualified, and you don't have the issue. I mean, what we would like to have is a safe Linux, but not necessarily all the toolchain also. So we could do a mix or something like that.
Yeah, I think that's a good point. I think, kind of the natural inclination for groups like this is to lean towards the open source tools because we're, working in the open source community. And I think that's where we can contribute. But it would be interesting to maybe do some analysis of like, hey, what are the major gaps in the tool chain that open source can't cover? And can we fill them in with commercial tools, right? And or at least while we try to cover the gaps in what the open source tooling is. I guess you can see from my bent, yeah, I kind of prefer open source tools, but I acknowledge that they don't solve every problem that we have to solve in the safety space. And so you're almost always going to need a commercial tool in one spot or another, I think, at least as the state of the industry stand today, from my perspective. So.
You could do it also stepwise. I mean, what we want, for example, is to kick out QNX, for example, and replace it by a safe Linux. If I do my static analysis with the commercial tools of the or the open source tool, I do not care at the beginning. Let's say,
yeah,
that's that. Yeah,
So maybe I can jump in, Matt. If that's fine.
Sure.
In fact, we actually did this experiment already in the past. So we used commercial tools. Where we obtained a license to use the tool for the purpose of that, or letting it run on that open source project, and we were free to share the results of that. Unfortunately, the main issue that you then encounter is that you identify that that tool has certain shortcomings, and then your ability to actually modify the tool, even though the modification might be very simple, you are limited to the commercial provider to do that change. And in the end, given that the commercial provider has no own interest in doing so, we were basically stuck having a commercial tool that couldn't be appropriately tuned. That's the fundamental problem that you encounter. Of course, you can overcome that problem with, I don't know, certain maybe investments, but then again, why would a community, right, be interested in investing into the product of one specific company? Again, there, that seemed obscure, and we didn't drive that further. So it shows that there's a certain difficulty in that. That once you need to have the tool tuned, or certain functionality, certain features need to be improved for the use in that project, so the Linux kernel, you're basically stuck.
Yeah, I think Lucas was touching on there. It wasn't his main point, but it's kind of a secondary point. It becomes a little bit harder to engage with the community because people can't replicate your results, right? Unless they go buy a license for this tool.
Yes, right. And even if you would have a license, right? So basically, the license is somehow you can use it for that specific project in that use, but then you're not allowed to reverse engineer the tool that you obtain and so on. And that makes it really difficult to engage in an open community, right? Because you could say, well, this tool has this rule, which I'm not allowed to talk about, that does this and results in these results, and I would want to change the rule to some other behavior that I'm not allowed to talk about, and so on. That makes it really complicated to engage with each other. And in fact, the commercial tools we tried out weren't that impressive compared to that what we saw with the open source tools. None of the findings that we encountered were specifically critical, and the noise ratio of the commercial tools were in the same range as with the open source tools. So yes, it's no surprise.
I do not discuss the fact that the open source is better than the commercial stuff. Sometimes this, for sure, this is like this. This is more that you have to make your tool conform to the process. No, I'm just thinking about some kind of hybrid use case. You know, that's we are using Yocto, for example. We build the ELISA Linux safe kernel, and then instead of using the ELISA tool open source, we could use also our own infrastructure to run our static code analysis with a commercial tool, and that something like this. Is it possible?
But yes. So that nobody would stop you doing so. It's just that, right? The question is, as a community, how would you engage? And the question is, can you share the results with someone else? Probably yes, that's still possible under your license. I assume it would be possible under your license to share it with others, what you found. Can someone else reproduce your findings independently? Probably the answer is already no at that point. Can someone actually fix an issue of the static analysis tool and independently check it? Probably also no. So then you are already in the responsibility of taking all the fixes that others are submitting and checking if they actually resolve the problem. And the other one is kind of operating blindly.
We can also submit the patch we do to fulfill our static analysis, and then we decide something like this that we submit. You don't need to share the results, but they're submitting the patch. And
you can certainly do that, and you will probably, I don't know to which extent you tried this, but you'll probably observe similar things as we have observed in the tool investigation group, that half of them are accepted because they are trivial and have no impact, and the other half is not accepted because it does have an impact and the value is actually low. But that's the general observation that you make when you use static analysis tools at the current state with the current quality of the Linux kernel. Again, all all the relevant static analysis tools have been run on the current Linux kernel source tree. So it's not surprising that many findings that you have been seen, at least in the past already, and possibly already discussed. But and I think that's one of the core issues that we wanted to encounter in the group in the beginning, is how can we actually address the problem of so many false positives of these static analysis tools, and how can we build up a database collaboratively that allows you to filter out all the false positives that have already been discussed in the past.
Okay, I understand. Okay.
And yes, we have an approach to do that. We know the action items to address that. But again, nobody of us further engaged on that. Again, static analysis isn't the showstopper to a safety argumentation for a Linux-based systems, in my humble opinion. But of course, if it is the only showstopper for you, go ahead, address it, and then you're done. But for us, it didn't seem, or at least for me, it doesn't seem like the most critical aspect to address. It's feasible, but it's, the quality increase is also, relatively clear, but relatively low.
Yeah, I agree with you, but to be safe, you need to fulfill things. If it makes sense
No,
or
you
not,
don't.
that's
No.
another discussion.
No, you don't. That's why I disagree with. To be safe, you need to reduce the risk to a acceptable level. That's what you need to do.
Yeah, I was going to say about tool qualification. One of the kind of general misconceptions about tool qualification: having a certificate for a tool gives you some level of confidence in it. So that's one way to be confident that you can use a particular tool. But tool qualification in the standards always involves you saying, what tool am I using for my project or for my product? For what purpose? Why am I confident in it? And one answer to why you're confident in it is it's a commercial tool that has a certificate. But actually showing that you are confident in it is not impossible, whether it's an open source tool or a closed source tool. It is more about your understanding how you're using the tool, what the chances are it can introduce a problem into your process, and not does it have a shiny certificate.
Yeah, and I think the other really important thing with tool qual that I've seen is the reproducibility, right? Because you want to be able to take the same code, run it twice, and get the same results. And with some tools, that is definitely not the case. In fact, we've seen some cases of that with coverage tools before, which is really interesting. So,
yes. So I think tool qualification is an interesting topic. Also, that we discussed in the past, but we haven't really driven that further with actions. But yes, I'm happy to see what the next year will bring in that direction. Again, the challenges are known, and I guess we can all tell you a story about it, but especially. I think especially at CodeThink, they have quite some experience on what does it mean to look at an individual tool, and what does it actually mean to look at it in a whole tool chain. And there's quite a difference. So Paul can tell you a lot about that.
I guess it's a good sentence, because also, as Paul already started to discuss a little bit about processes, confidence, the next item would be the open source engineering process. And it's just